Myth
I
was
forgot
never
he
a
existed.
thing. He was never good.
Oh, I wouldn't say
There
he
we
was
go.
good. I'm saying in terms of popularity, he fell off like heavily.
Okay, it's up now. I don't know what that
It's
was.
because all the 9-year-olds started watching Ninja.
Okay, so looking at number 7, Bridget gave us the suggestion. Obviously, part 1, everybody should have got part A. Part B, Bridget said she plugged in A and B, or X and Y, sorry, and solved for K, which is a wonderful idea. I would do that. You can do it in more than one place. It doesn't really matter. I would definitely put it in, personally, the top one, the Y equals 2x plus K up there, because it's going to make your life easier. So negative 213. So you get, see, so we get 13 is equal to 2 times negative 2 plus K. And then at that point you get, what, 4, so 17 equals K. So that's the first thing we need to do, is solve for our K value. Now that we have that, we're looking for the coordinates of B, and it tells us that the curve intersects the line at 2 distinct points. So how are we going to find coordinate B?
I set them equal to each other and
B.
then like factored it.
Okay, so you gotta be careful. You want to be a little more specific.
I solved for x. Okay, I set the y equals 2x plus 17 and then the 5 minus 2x plus x squared equal to.
So you set the right-hand sides equal to each other, which we've already done in part 1, so I can just replace my K value to make it a little easier for you. So you don't have to write all that back out. So x squared minus 4x plus 5 minus 17, which is minus 12, which is equal to 0. Solve for your x, so at negative 6, positive 2.
Oh wait, I got 6 and negative 2.
That will not be correct, because then we won't get the same coordinate we already got. We should get negative 213 for one of them, which we will, which is why it has to be x plus 2. That gives you a hint on what one of your answers has to be. One of your answers has to be that negative 213. If it's not, something's wrong. So we need to get x equals negative 2. So in our case, the other one is 6. Plug 6 back in to any equation to get our y value. I would choose, again, the easy one.
No, that's what I meant. Like, I got 6 and negative the answer, not like...
Oh, okay.
In the
2 times 6 plus 17. So y is equal to 29. So our answer should be 6. 29. If I did my math correct. Yep. Okay, now somebody besides Bridget. We are part C. For the case where the line is tangent to the curve at point C, find the value of K and the coordinates of C. So how do we find where the line is tangent to the curve? Don't all go answering at once or anything.
A derivative.
That would be a great idea. So what do we know about their derivative, somebody besides Thomas?
They'll be equal.
So yes, I should be having a lot more people answering these questions.
I'm really trying to catch up.
So if you take the derivative of both, you get negative 2 plus 2x and y prime equals 2. So in this case, we don't even have any k values in our derivative, so this makes this problem actually quite a lot easier. So we can set those equal to each other, so you get negative 2 plus 2x equals 2, 2x equals 4, and x is equal to 2. So we have the coordinate x coordinate. We can find the y coordinate, because there's a couple different options you can do. The easiest one is you can find the y coordinate by plugging in to your original parabola, and you can find your k value by plugging into when you set the two equal to each other. So both these, this is a relatively straightforward question. So I'm going to plug it in to here to find my k first, just because that's what I want to do. So you get 2 squared. My k is equal to 1. And then I'm going to plug it into actually my linear function just to make my life a lot easier. So y is equal to 2 times 2 plus 1, so y equals 5. So your coordinates are 2, 5 for C, and k is equal to 1. Any questions on that one? Okay. 8.
Wait.
Go ahead.
Why did you plug in the prime back into the other equation?
Which other equation, be more specific?
The x squared minus 4x plus 5 minus k.
To solve for k, because it tells us to solve for k and find the coordinates of C.
It told you to solve for k again?
Well, it's a different k now. The first k in part 2 was for that intersection. Part C, it's a different k value.
Okay.
Different k values will have different consequences. Either they will make the line intersect the parabola twice, one time, or even no times. So that's what a different k value will do. Because if you think about it, it's going to shift that line up or down very easily. So if I shift the line so far down that it's below the parabola, it'll never intersect the parabola. Or if I shift it up enough, it's going to intersect 2 times, which is what happens in part B. And if I shift it just right, it's going to intersect once and be a tangent line, which is what they're asking you to find for K in part C. Okay. Question 8. The curve has the equation, blah, and line has the equation. Show that the curve lies above the x-axis. How do I do that?
Can you find the vertex and then show that it's above the x-axis, and since it's opening up because the x squared is positive, you can prove it that way?
That is one option, yes. That's a relatively easy option.
Cool.
Is there any other options? There's a...
Probably.
You have to prove
There-
that the vertex is above the x-axis.
That's one option, yes. That's not a bad option because it's a relatively easy thing to do. But it's not the only option. It's not the easiest in my opinion. So if it's above the x-axis, I guess, yeah, you need to show that it's above the x-axis. That probably is the best option. But also don't forget, like we talked about yesterday, the discriminant is very powerful for quadratics. So finding the fact that the discriminant will actually be negative in this case, because if it's above the x-axis, that means it won't have any x-intercepts. So there are no solutions. So you can show that the discriminant is less than 0, giving you 2 imaginary answers, is one option. But since it says specifically it's above the x-axis, your vertex method probably is the easiest. So yeah, you can do that. So what's the function? Y equals what? X squared.
Minus 5x plus 7.
So take your derivative, 2x minus 5. Set it equal to 0. You get x equals 5 halves. And then show your y value. You got to plug your y value back in at that point. So y is equal to 5 halves squared minus 5 times. Common denominators or calculator, I don't really care. So is that 28? I get a negative number. What did I do wrong? X squared minus 5x plus 7.
It should be 3/4, I think.
No, it's definitely 5/4. Or 5 halves. I mean. Where'd you get 3? Or if you add those together, you get. Did I do the math wrong in my head real fast? 25 divided by 4. Oh, I guess I did. Oh no, I messed something up. So yeah, that's right. Thank you, Ken. So y is 3/4. And then you, it's not just enough to show that the vertex. So we found the vertex is above the x-axis, but unfortunately that's not enough information. We need to do one more thing. Any suggestions?
Do you have to make
put
sure
it
that
on
it's
number.
concave up or something?
Cavity.
You don't have to do concavity, that would work. But
I put
it's much easier.
I put it on a number line to make sure it was the minimum, so it was like the lowest point. I don't
You could do that. That works as well. Again, that's not the simplest way. Simplest way is just say it opens up because x squared is positive. Since it has a positive coefficient. Okay. So all you have to do is just say that x squared has a positive coefficient, opens up. That is mathematically correct. If it opens up, and that, then you could make like a little statement, the vertex is the lowest point, whatever. You could also, like you was mentioned, you could show that this is a minimum value right here, so you could use your first derivative test to do that. You could also do concavity, so it's concave up. I don't know if the concavity would be a good enough definition unless you also make the statement that that is the lowest point and it's concave up. But quite easily, it's just, it should be more than sufficient to say it opens up since x squared has a positive coefficient. Okay. I am not going to do part B. We've done like 5 of those already. And part C, we've also done inequalities. Just to go over real quick to make sure everybody remembers this, how do you solve a quadratic inequality?
Number line.
So you had to do a little more before you get to the number line, but yes, number line, Miguel. So remember, get it equal to, quote unquote, get everything on one side and get it compared to 0, and then use your number line analysis just like a first derivative test. But we've done plenty of those. I don't think I need to do another one. So curve has the equation that expressed in, okay, so once to complete the square there, it is slightly more difficult than a normal completing the square, so I'll go ahead and do this. So y equals 10x minus x squared. If we're going to complete the square for it, you have a couple of options. What I would do is rewrite this as negative parentheses x squared plus 10x, because you do need to factor out that negative, plus blank, in order to complete the square. So that part's the easy part, in my opinion. Obviously, cut the 10 in half, you get 5, 25. The real question is, what do I put on the outside? Because I can't just add 25.
Negative out, would it be negative 10?
Oh, yeah. Wasn't paying attention. Thank you, Thomas. Okay, so fix that error. Thank you. Now again, the question is, what happens? What do I put on the outside? Because I can't just add 25. This is not an equation. It's not going to add 25 to both sides or anything like that. I've got to compensate now for adding that 25. So what do I do?
You gotta say 25.
That's what most people would say. Unfortunately, that is not correct. Did I really add 25?
No, you have a negative out front.
I have a negative out front. So I've actually subtracted 25. So right now I've added a negative.
25?
So I will actually have to add 25, yes. That's where you got to be really careful and watch if there's a number out in front or if there's a negative sign out in front, you're actually doing it that many times or a negative version of it. This goes back to when you did completing the square with like your hyperbolas and things like that in pre-calc. So like if I would have had a 2 out in front, which might happen in some problems, then I'm not adding 25 at this point, I'm actually adding 50. So I would have had to have subtracted 50 on the outside. You always got to be mindful of if there's anything out in front of your parentheses. We don't tend to do a lot of them, but we do some of them. Like I said, you mainly do it in pre-calc with your conics. And then you just factor it and put it in the form they want. So this becomes 25 minus x minus 5 squared. So I just moved the 25 out front and then factored it. And now it's in the form that they want.
How do I know when I should be completing the square as opposed to just trying to like?
You could multiply out the a minus x plus b squared. You could multiply out the squared part and then set them equal and do that as well. That is a viable method. It's just a lot more work in my opinion than this one. This one's really easy to complete the square. Typically you actually do completing the square if you notice if it's just x plus something squared or x minus something squared, because that's the easy way to do it. You can complete this part B, write down the coordinates of the vertex. I don't really know why they gave those 2 points. If you've done part A, this is in vertex form for a parabola, which you probably don't remember from pre-calc. So all you have to do is just realize that the vertex is 5, 25, and you're done. Like, that's literally all you have to do. I don't know why they would have given that 2 points. Usually, like, that would be like one question, A and B together. It would say express this in the form, or otherwise find the coordinates of the vertex or whatever. So that's typically two things that go together. They're not going to ask us as two separate questions.
Wait,
Why what?
why is the vertex 520?
Because that's vertex form, HK.
Huh.
I mean, if you want to find it, you could take the derivative, set the derivative equal to 0 if you really wanted to. So if you did the whole y prime method, you'd get 10 minus 2x. So x would equal 5. When you plug 5 back in, you get 50 minus 25, which is 25. So it doesn't matter which way you do it, but that is vertex form, in case you don't remember. So you could have it different ways, but it's x minus h squared, and then k. So the actual form that you probably would have been used to seeing would have been x minus h squared plus k, and then that equals y. And the negative out in front has some meaning, but it doesn't change the h and k's and stuff like that. So that would have been from pre-calc. Again, if you don't remember that, you can do the derivative, find the vertex. They didn't say you have to find the vertex using that. They just said find the vertex. It just makes it easier if you remember that's vertex form. And then part C, find the set of values for which y is less than 9. How am I going to do that?
A number line?
Not quite.
Or, well, inequality?
There are multiple ways you can do it. I would personally do a pretty simple inequality. I thought I said less than. Let me check.
It has like a little line underneath, but I'm not sure because it's not like.
It does, yes. That's less than or equal to. Thank you.
Okay.
Looking at the screen that well. So what I would do, take our equation here. They've had you write this equation and complete the square form for many reasons. So if we have y is less than or equal to 9, this is y. I can replace y with my lovely equation here. And then solve that inequality, which is relatively easy because they've done most of the work for us. I'm going to add the x minus 5 squared over and subtract the 9. So I get 16 is less than or equal to x minus 5 squared. You can do that and then solve this quadratic inequality if you want to. You do have to be careful. Most people are going to say square root both sides and things like that. You're going to get into some messes that way if you're not careful. Because when you take the square root, you have to be careful on what exactly is going on. But you can do it. So if you take the square root, remember you have that whole plus or minus thing looking like that. So there's a couple ways you can do it. I do it the common sense way instead of doing it that way. And look at this. The number in here has to be bigger than 4, looking at the positive case. So that's easy. So this goes to x minus 5 has to be bigger than 4. That's the positive case. No big deal. Positive case, super simple. The negative case is always where you have to be careful. What do I know about the number in here compared to -4 to satisfy this inequality? Okay, so again, if we look in the parentheses and ignore the fact that it's x minus 5, we're saying what number has to be in there in order for it to satisfy this inequality. I'm talking about negative numbers. Well, clearly we know -4 works because -4 makes 16. What does the rest of the numbers look like compared to -4?
Less than -4?
Why do they have to be less than -4?
Because when you square it, it comes out positive.
Right. So when I do this, what I look at is I look at the value of the number itself. Does it have to be bigger than 4 or smaller than 4? Since I'm squaring it, I don't care about the negative. I just need the number itself to be bigger than 4. So in the negative case, we have to be careful and realize that that means the number needs to be smaller than -4. That is, so you have to be careful when doing your square. You can't just square root both sides and put a plus or minus there. You have to take more into consideration than that because it's an inequality, not an equation. And then solve these. These are pretty easy at that point. So x has to be bigger than 9, and x has to be less than 1. And or. So that's your one option of doing inequalities. Again, the reason I do it that way is to show you and caution you when doing your inequalities, you have to be careful. It's not enough just to square root both sides, put a plus or minus there, and say I'm done with it. Does everybody understand how I got those two inequalities?
The way you're explaining it makes sense. Me looking at it makes
Can
no
you
sense.
go over it one more time?
So
Okay.
ignore the fact that it's x minus 5. Just pretend it is 16 is less than blank squared. Or greater than or equal to, sorry. So what has to go in this blank? Well, I could have two options. I have a positive case and I have a negative case because I'm squaring it. So always do the easy case first, positive. What do I know about the positive case? Well, if it's positive, you find your value that, in this case, makes it equal to. So I know that 4, which is the thing, is less than or equal to blank. Whatever's blank is, I don't care what blank is. Because if blank is 4 or bigger, when I square it, I get 16 or more. Then you have to do the negative case as well. So find the negative number that satisfies this. Well, -4 is the first number, because that would also give me 16. Then I know I need my number to be smaller than -4. Because if my number is smaller than -4, it's things like -5, -6, etc. Sorry about that. So that's how you look at it. That's the best way to look at it. You need a positive case and a negative case. Negative cases are always messed up. Remember that because they have special rules with your inequalities and things like that. Somebody's echoing. I think it's Thomas.
Whoops.
You're okay, buddy. So that's how you get the negative case. Negative case is always going to be your more complicated case you have to be careful with. We need numbers, and again, we're looking at the magnitude of the number. I don't care about the sign in front of it because I'm squaring it. I just need the magnitude of that number when I square it to be bigger than 16. So that means for the negative case, I actually have to go smaller than to the left. So -5, -6, -7, -8, etc., etc. And then you just fill in your blank with the x minus 5. X minus 5. Okay, does that make sense, hopefully, now? Okay. I'm gonna take the silence as a yes. Alright, moving on to number 10. Okay, so they give you k in this case, and they want you to find the points of intersection. Okay, so do I need to find the points of intersection for anybody again? I think that should be pretty easy by now, hopefully.
I think we're golden.
Okay, does anybody need me to find those points of intersection? Because I can if you need me to. But I think we've done about, I don't know, 7 or 8 of those by now.
I'm good.
By looking at the answer, you probably won't be factoring. Because it's -1/2. Oh, it's the midpoint, never mind. Okay, so yeah. Everybody remembers the distance formula, yes?
No, honestly.
Okay, so you don't need to memorize the distance formula in this case, but it does help for most people because they use it. But all you have to remember is the distance formula is nothing more than the Pythagorean theorem. Okay, so remember when you have, especially when you have 2 coordinates, so if you have like A is here, B is here, you can always draw your right triangle, especially if you have 2 coordinates. So this would be like, I don't know, let's just make this -3 and this would be like 5. Well, the distance between A and B is -3 squared plus 5 squared equals c squared. You can always do it that way. If you want your distance formula and you want to use your distance formula, remember it is this right here. Some people really just like to use it instead of the Pythagorean theorem. I use the Pythagorean theorem. So if you want the distance formula, it is there for you if you want to write it down. It's not necessarily a bad thing to use or memorize. I just prefer to use the distance formula or the Pythagorean theorem on a coordinate plane. And then I'm going to assume, again, it's not a good thing, but assuming that everybody knows how to find a midpoint.
Yes.
You just
Wait. I actually have a question about that. Can you please do that?
finding
I'm
the
confused every time I do that.
midpoint again has a formula, which is you're just finding the middle. So to find the middle of any 2 things, you add them and divide by 2. You're finding the average of them. So there's a lovely formula for it. I just remember that it's you add them, it's the average, the middle of them. So you just add them and divide by 2. But there's a formula for it. Okay, and then B, find the 2 values of k for which the line is tangent to the curve. Again, we've done that plenty of times. It's just doing the work for it, so I'm going to leave that. You can find the answer, so. Anybody who did it and got it wrong have any questions? Okay, number 11. Again, finding a midpoint. I don't think I need to do much of that. Getting more tangents, okay. Any questions on B? I mean, like I said, we've done plenty of those. I think I can leave that for you guys to do if you haven't already done it, which you're supposed to. For anybody who did 11B and not get the correct answer, anybody have any questions on that one? Okay, A12, 12, I will do at least the completing the square with the number out front like that, because it may have been a while since you guys have seen that. Okay, 2x squared minus 4x plus 1. So 2x squared minus 4x plus 1. So here, if we want to complete that square again, this is completing the square, but instead it's having a number out front. So what we're going to have to realize is, just like we did before, we're going to factor out the 2 out of the x squared and the 4x, but not the 1. That's the mistake that most people make. We don't have to factor a 2 out of everything. We only have to factor a 2 out of the first 2. And then we can use that to complete the square. So at this point, after we factor out the 2 out of just those 2, it becomes really easy. Cut the 2 in half, you get 1. 1 squared is 1. The real question, though, is what do I put on the outside blank? That's what you have to be careful on. It's where a lot of people make their mistakes. So what's going to go in the outside blank in this case?
1? Or
2.
-1?
How'd you get 2, Michael?
You have to multiply it by the outside.
You have not added 1, you've added 2. If you were to distribute this 2 out, 2 times 1 is 2. So I've actually added 2. And you got to be careful. I have to then subtract 2. So you have to be extremely careful when doing all these things and making sure we're paying attention to those details. Otherwise, we'll get the wrong answer. So if I add 2, I then have to subtract 2 to compensate for that. So then factor this becomes x minus 1 squared minus 1. And here's a really easy way to check and see if you did it correctly. What can you do? How can you check to make sure you did that part correct?
Multiply it out? Question mark?
That would be correct, yeah. All you can do is multiply it all out. If you don't get back to 2x squared minus 4x plus 1, something's wrong.
Facts.
Yeah, so that's all you gotta do is just multiply it back out. And see if you got it right, yeah. Let's see, so for... I don't think I need to find the coordinates of the minimum point. So I don't think I need to do that. You can do that through either calculus or they give it to you. They give you your vertex form. So the coordinates of the minimum are 1, -1. Alright, and then part B gives you a line and then the same curve. Tells you it intersects twice. It even gives you point P. I don't know why it gives you point P. But okay. Find the coordinates key. I don't think I need to do that. Do I need to do that for anybody that has actually done it and got the question wrong? For those of you that haven't done it, you need to go back and do it, please. Okay, and then part C, find the equational line joining Q to the midpoint of AP. Well, you've already found A, and they gave you P. Okay. Well, shouldn't be too bad. Remember, how do we write the equation of a line, people? This one is one we should definitely know how to do.
Point slope form.
Yay, point slope form. Do not forget point slope form. So obviously they're requiring you to find the slope of AP. Actually, no, they're expecting you to find the midpoint of AP, my bad. And then use Q and P as your point, or Q and whatever the crap you want to call that point. Whatever letter you want to use. Find the slope of that line, and then use either Q or the midpoint, and put it in point slope form. And regardless if they have their, actually they left their answer in point slope. Usually they put them in slope intercept, but they even left their answer in point slope. So that is something that is not terribly difficult for us since we've written plenty of equations of lines, hopefully. You do not struggle with that. And you can do that if you have not already done that. Okay. Any questions on anything I went over today or in general at this point about this stuff?
No.
On part A for 12, why do you add one and subtract two?
Because I didn't add one. I've actually added two. Because this 2 sitting out front, I would distribute to that 1. So it's really 2 times 1. So if I've added positive 2, if I were to multiply that out, I actually have to go back in and subtract 2 to cancel that out. Does that make sense, Abby?
Yeah.
Okay. All right. I have just assigned, so I can't forget, the end of chapter 2 exercise, which is functions. Again, same deal is going to be as we did last week. That is going to be due, actually, hold on. Are we done with AP Classroom at this point? Sign in. I think we did the last one. So we just did 6. I think we've already done 7, if I remember right, in this class. We did do 7, and we don't have to do 8. You guys are fortunate. All right, so AICE Math will be on Monday this week, since we do not have an AP Classroom assignment. We will have more stuff for that, and I'll be posting some stuff. I got to finish up making the assignments, and we'll discuss that more on Monday after I have them all completed on there. So you'll still have stuff to do on there, but the AICE Math will be due. We'll start going over it on Monday this week. So make sure you have some stuff done. It's functions, so like your fog and golf stuff, things like that, all kinds of different things. I know, right? Sketching graphs. Apparently they have you doing one of them. One of them has you like complete the squares. I'm looking at it. But there is some things in there, such as inverses, and then your composite functions, like I said, things like that. Domains, ranges. It looks like they have some, whatchamacallit, piecewise functions. And again, there are 13 questions this time. So make sure you have, I would say probably 5 or 6 at least done by Monday so we can start going over that. If I feel people do not have stuff done on Monday, just as a warning, I will start making you do photo submissions for all of this before it's due.
I will personally kill you if that happens, so yeah, let's not.
So I'd rather not do that, but if I get the feeling on Monday people don't have a majority of this done, or at least like 5 questions, I understand they're like got A, B's, and C's and stuff, but if we don't have at least some work done, then I feel like I'm gonna make you go to photo submissions. So I don't want to, but I'm just warning you.
And I will personally make homeless men call on you.
Apparently Miguel knows homeless men. All right, so any questions from anybody?